dependent variable should be categoric. Dependent variable metric or interval scale data, like demand for the product, sale, etc. on the base of set of variables. So there is usually very well commonly applied technique is a regression analysis. Even if you take a bank, if you want to understand the performance of bank, performance on what basis, profitability of the bank, many ratios are there. So the main component is the internal based performance. So what is the internal based performance of the bank? ROA, return on asset. How much they return, okay, based on their asset, how much they are able to generate the income for the bank based on the assets. Assets again classified as a two types. All those things I believe, fixed assets and other types of assets. Okay, fixed assets means land, whatever they have their own branches, etc. And other types of assets means the advances they are giving. Because of that only they are getting the interest, advances, the debentures or bonds, whatever. So, how well they are utilizing these assets to generate the income. So that will be reflected by return on assets, ROA. So that will measure the internal performance of the bank. So if I want to study that ROA, I can take ROA as a dependent variable. Then what are the possible independent variables? Different ratios. You can take the liquidity ratio. Okay. You can take the credit risk ratio. Many ratios are there, financial. You can take them as the explanatory variables. Non-performance asset ratio, long-term debt to total asset ratio. Like that way, different ratios are there. These are the secondary data available in the bank's annual report or any other website. Okay. Okay, so we use some PPTs are already there, so I don't know. Okay, so that was the usual regression, and we understood. So when you develop a model, what are the things to be done? Validation of the model. Okay, any model when you develop, you have to go for validation. So validation is nothing but what? The overall significance of the model, individual parameters of the model, individual variable significance, then through the R-squared value. So many things we did it. And before developing the model, we can also check the assumptions, normality assumption, linearity assumption, etc. So we understood in detail. Okay, I have not yet opened the PPT. Okay, just I am going through orally. So I'll start that one now. So he's asking that PPT. Okay. So now in the last class, I started another model. Okay, that is the discriminant model. So what it tells in the discriminant model, the dependent variable will be categorical variable. It takes the nominal data. So either yes or no category. So if you take only yes or no category, it is a dichotomous, but it can have more than two categories also. But anyhow, it is a nominal data. And we are going to have a set of explanatory variables. That means independent variables. For what purpose we can use this discriminant model? Discriminant model can be used for classification. That means to find a group membership of an object or an individual. So I have given an example, like when a customer enters some mall, the decision maker, whoever looking after that mall, the concerned person, he would like to find out whether he is going to be a buyer or non-buyer, whether he is going to make a purchase in the mall or not. So we can classify. If he makes a purchase, we can put him in a buyer category, and if he does not make a purchase, we can put him in a non-buyer category. So that classification we can find out. So what is the probability? We can find out the probability also. What is the probability? What is the chance that the new customer arrival going to be a buyer? So what is the probability? So higher the probability means he is almost going to buy. That means he can be put in buyer category. So lesser the probability means he is not going to purchase. So he can be put in non-buyer category. So for this classification purpose, we can use this discriminant model. So discrimination is a classification. Okay. Another example, I think I given the popular example last time. That is a social networking site. So that means the people using the internet, social networking site. A high user and low user, we can classify. Nowadays, depends. The people in the sense maybe including students also and the working people, etc. For different reasons, you people are using the social network like internet, like a Facebook, WhatsApp, other types of social media you are using, blogging, etc. you are using. Totally internet, high user and low user, you can say. What are the different reasons one is using that social network, that internet, to connect with the people, for some people, and to get some educational information, for some people to make a friendship, clear. Then some people is just messaging, chatting, and also we can say that how to classify them as a high user or a low user, depending upon how many hours they use on a weekdays, how many hours they use it on a weekend. We can create. So these are the variables will decide a new person, okay, who is using the internet, social network, whether considered as a high user or a low user. Okay, so that is called the discrimination, discriminating. So dependent variable must be categorical variable, independent variable may be of any type here. So you can see the difference between the earlier multiple regression model and this discriminant model. We have to develop. That means we write a model in the similar way like a multiple regression only. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2, like that way we write it. And the important thing is that how to estimate these parameters, means coefficients of independent variables like beta naught, beta 1, beta 2, how to estimate. How did you estimate in a multiple regression? With the help of ordinary least squares method. So in the statistics, what is important, of course, you people are using directly the SPSS, it will give the output. But what is the concept behind that? The important thing is that when you use a model for regression, discriminant or anything, when you write that mathematical structure, mathematical model, the coefficients of that equation should be determined with the help of the sample data. In other words, to be estimated. How to estimate that? So in the regression we did by the one method called the ordinary least squares method, means minimization of the error sum of squares. Whereas in the discriminant model, it is a different way. So we don't apply that OLS method. Here we method the maximization, centroid method we use it. Okay, two methods are there. So I explained that in the last class, just I'll go through. You can see that one. This is a thing. The applicational, you can go through that later again. Has anyhow PPT is there. See, objectives of the discriminant analysis, uses of discriminant analysis. 4 different objectives are there. We are interested in a segment discriminant, means classification based on the key variables. So examples are given, like a wool manufacturer wants to know the characteristics of the fiber that differentiate between the prospective buyer and non-buyer of a product. What characteristics the buyers are expecting in the fiber to purchase or not to purchase? Whether the durability of that is important, lightness in the weight, low investment, rot resistance, like that way. This is one example. Based on this, we can classify whether the buyer of a wool or not buyer. The other one I had taken the admission procedure in Alliance University, how the students are passed or failed in the admission test. So based on the written test score, group discussion score, interview score. So which one is the predominant? We can find out which one is more influencing to say that the student is passing in the test to eligible to join the university. Okay. So which variables are more important? Similarly, suppose if I take SBI, the credit rating of the consumer, okay, as a high risk, default payment. So how do you say the income of a person, the age, years of marriage, relevant or not relevant, doesn't matter. Initially they are taken, or classify the salespeople as a successful or unsuccessful, just grouping the people into successful category, unsuccessful category. Similarly, the most important, last one I given an example. The highly user of a social networking site, internet, and low user. Time spent on the networking site during the weekdays, weekends, for different purposes, messaging, to make a new friends, to promote the events, blogging, news update, games, education, etc. So all these variables will help you to classify a person to one of the categories. Which one will influence more to become category like a high category, means a high user of a network. So what is the probability that an individual is a high user of the network, social network? So that depends on one or two or three of these categories, variables. Okay, we can identify what are those. So we have to develop, we'll have the data. And these are the assumptions, similar like a larger regression model. In the discriminant model also, the independent variables must be, predictors variable must be independent, means there should be no multicollinearity. Among the independent or explanatory variables, there should be no multicollinearity. So otherwise what happens? Same variables will define the same thing, that is not required. So we expect the no multicollinearity. Then all pairs of predictor variables must be linear. Okay, predictor variables must be in a linear relationship between x1, x2, etc. And there should be no outliers. Okay, outliers means what? Some observations may not belong into that group. Okay. So these are all the things, and normality assumption of the predictor variable. That is the most important assumption. So one has to check all these assumptions before carrying out the discriminant model. So this is the usual model setup, similar like a regression model, beta naught, B1, etc. are the coefficients. Now, how to estimate this? Discriminant function coefficients they are called. Based on that, we get the value of y, that is called the discriminant score. When you substitute the value, look here, when you get the values of beta naught, beta 1, beta 2, etc., B naught, B1, B2, then when you substitute the score, values of variable, you get finally one numerical value, that is called the y value. That y value is called the discriminant score. Now, this discriminant score value of one respondent should be compared with some benchmark value, cutoff value. Then only we can able to classify whether he can be considered in this group or that group. Okay, so this y value is taken as a discriminant score. So that should be compared with the cutoff value. I will explain how to calculate the cutoff value and then classify. So if a person is value, that individual respondent value, that discriminant score is more than that cutoff value, he will be put in one category. If it is less than that value, he will be put in another category. So that is what the discriminant score. So we can also calculate the predicted probabilities from the discriminant score. That means the probability of an individual or a respondent being in a particular category of the dependent variable. So what is the chance that an individual in a high user of social network. So we can find out what is the probability that the individual can be in a buyer group. So that probability is also we can calculate. Anyhow, SPSS will do all those things. You are not doing manually, but concept you should know. So for that, what is the important is the eigenvalue here. So what is the eigenvalue? It is a ratio between the group sum of squares to the within group sum of squares. If you remember the last multiple regression ANOVA table. So in the ANOVA table, we have the components called the sum of squares, the regression sum of squares, error sum of squares, then the total sum of squares. So that is a ratio only, F ratio. So F ratio in ANOVA table, here we call it as an eigenvalue. What is the purpose of that eigenvalue? You'll come to know now. So that means we have to go for estimation of that coefficient, like beta naught, beta 1, beta 2, we have to estimate. There are two methods. In the regression model, we have ordinary least squares method. But now here we have the two methods. One method is called the centroid method. The another method is the eigenvalue method. Two methods are there. In the back end, you are not going to do that one directly. Okay. In the back end, in the SPSS, these methods are available. Just you have to use that to estimate the parameters of the model. So that is I have explained. Method 1 is a centroid method. Method 2 is the eigenvalue method, maximizing the eigenvalue. Normally we use that centroid method. So you can go with any method when you use the SPSS. Okay. Then we are going to have the cutoff score. As I said just now, no? Cutoff score. Now, how to calculate the cutoff score to classify whether a person belongs to this group or this group? We have two methods. Suppose in both the groups, initially if you have the equal number of observations, then the first method is simple. Like you have to take the combined average. First you have to find out the mean value. Okay, two different groups mean value, and then you have to take the mean of that values, whole combined average. Suppose if you have the different sizes in your group, in the group of first group and the second group, then the cutoff score can be taken like this way. The second method I have explained. So what is the next one we have? Next one we can find out the correlation matrix. These are we have to understand the output of the SPSS. It will provide this correlation matrix. Usual correlation means what? Suppose the relationship between any two variables. Now here, what is the difference in the correlation matrix? See, correlation between what and what? The correlation matrix for the entire predictor variables helps to detect the problem of multicollinearity. That means we're going to have, let us say that you have the 5 variables here and 5 variables here. You will get the correlation matrix. Normally, if the correlation between any two variables is more than 80%, 0.8 and above, then those variables are highly correlated. That means there is existence of multicollinearity. Lesser than 0.8 doesn't matter. Okay, that is a standard, set standard for understanding. So that is what the correlation matrix. Next one is what? Another type of correlation, the canonical correlation. What is this canonical correlation? It is the correlation between what and what? Between the discriminant score and the coded values of the groups. That means the individual variable. See, after substituting, you will get the values of y. That is the discriminant score values you will get. So y values you will get it as sum. For each respondent you will get it. Suppose if you have some 50 customers, 50 respondents values, y values will be there. Now this discriminant score versus each individual variable, x1, x2, etc. separately, that indicates the canonical correlation. Now what is the purpose of that? What it does? Canonical correlation, how different from the earlier correlation between the two variables? Canonical correlation indicates the percentage of variation in the discriminant model that is explained by the predicted variable. So it is similar like in the multiple regression model, capital R square. So if you're able to recall, capital R squared of the multiple regression, the purpose of R squared was coefficient of determination. What percentage of variation the dependent variable explained by set of independent variables. So that work here in the discrete model will be executed, will be done by this canonical correlation. So once you find the canonical correlation, you have to square that value. After squaring, you have to interpret in the similar way like a R squared only. Then we have to go for the contribution of individual variables also, like whether the individual variables in influencing in classification of the individuals are object to one or the other groups. So which are the variables are highly influencing? So which are the variables will provide you the higher probability of classifying into that particular category, like a high user of network or a buyer, etc. So for that, again, we have to go with the table only. And when you take the discriminant model from the SPSS output, again, there will be two types. Unstandardized means that beta naught, beta 1, beta 2, etc. measured in the original units only. Because we are using the different variables, different units will be there. So original units, if you take, this is unstandardized. Suppose if you don't want that different units, if you want to convert everything is a standard normal variable, then that is called a standardized discriminant function. Anyone you can use it. Okay. Standardized means is a Z-score. All the variables initially converted into Z-score and it will not be measured in units. Whereas in the unstandardized, all the variables will be taken as it is. Okay. With the original units only. Next, we have the structural coefficients. The next definition. The structural coefficients of predictor variables, I'll explain through the example later, are also useful in finding the relative contribution of the predictor variables in discriminating between the two groups. That is what the structural coefficient means. Same thing, whatever I explained, beta naught, beta 1, beta 2, beta 3, etc. How much they are influencing in discriminating, that is here we call it as structural coefficient. Then the discriminant of function model significance we have to check. Similar like a multiple regression. Here, how do we do that one significance of the overall model? Earlier, I did it by the ANOVA table in the multiple regression using the F square, F value. But here we can do that one with the help of the Willis lambda. So what is that Willis lambda? That formula is not required. Okay, but how to use that one to test the significance of the model, you should know. Look at that one, I have given. Willis lambda is used to test the significance of a discriminant function, whether the model is significant in classifying or not. So what is that actually? It is the ratio of within group sum of square to total sum of squares in a one-way ANOVA, similar like a F ANOVA table only. And it ranges from 0 to 1. Lower the value, the better is the function in discriminating between the groups. So if you have the Willis lambda closer to 0, lesser value, that means your model is very good in classifying the individuals or objects into different groups correctly. So the classification accuracy will be more with the help of the model. So that is what is the purpose of Willis lambda. Now, what percentage of accuracy you have? How much your model will be able to classify? Will it classify 100% or not? You can check by two methods are there. One is the hit ratio method is there. Second one is the maximum versus proportional chance criterion. Okay. So what is the meaning of that accuracy classification? First of all, you will have the set of people. Let us say that bias group only. If I take some 40 customers initially, I know that out of 40 customers, 20 are, let us say, 20 are the buyers, my previous experience. And remaining 20 are non-buyers. I know already. Now, what I will do, these people are giving me some score on a different attributes. Like if I take that example of wool manufacturing, they are giving the score, means how much they prefer for durability or rot resistance, different variables or no. For that, they will give the score, means the Likert scale data. Whether it is a very important for them or not. When they go for purchasing the wool, durability, is it important? Some people say that yes, it is highly important for me. So he will give a score as a 5. The interval data. Somebody will say no, not so important, but it is important. So he will give the score like a 4. Somebody says that not at all important. So he will give this value as 0. So these are the scores given by the different respondent customers. Okay. Now I already know that 20 are buyers and 20 are non-buyers. Now what I will do, I'll use their data, that scoring what they were given, all the 40 people. I can use the complete 40 people, or I can split that one into 2 groups, however I can do. Using that data, I will develop a regression model, means a discriminant model I'll develop. Using that observations only. Now, afterwards again, I would like to go for a cross-checking. Whether my model will able to classify that person correctly or not. So what I will do, I'll take the first person belonging to a buyer group. I will use this model. Whether this model will classify that customer correctly into that group. He should be which group? Buyer group only. So whether my model will classify it into buyer group only, there is a possibility of misclassifying. That means even though he is a buyer, that model may misclassify him as a non-buyer. Or even suppose if he is a non-buyer, model may misclassify as a buyer. So what accuracy level in classification would, that is a very, very less percentage. Like misclassification is very less. So what highly? So buyers, out of 20 buyers, how many of them are correctly classified into buyer group only? Let us say around 18 people are classified correctly into buyer group. So 2 are misclassified. Means model unable to understand that they are belonging to buyer group. Therefore, it is classified them as non-buyer group, even though they are the buyer. So it obviously what happened? Not 100% accuracy in my model. So, but almost 85 to 90% is there. Out of 20, 18 are correctly classified. So model is very good. Similarly, when it comes to non-buyer, out of 20 non-buyers, let us say that 17 were correctly classified as a non-buyer only. So remaining 3 as misclassified as a buyer. So there again we have the accuracy level. So we can't expect 100% accuracy in our model, at least very close to 100% accuracy in a model. So what does it mean? When the new customer comes, for example, 41st customer comes, we don't know whether it's a buyer or a non-buyer. But what we do initially, we give the questions to him. What is his scoring on durability? What will be scoring on rot resistance? What means his priority for that? So taking the data, we'll put the data into model. Then we can able to classify him, whether he belongs to a buyer group or a non-buyer group. Okay, so that is what we can do it. One is we can develop the model, and we can also use the same model for checking. That means whether the new arrivals, new customers are buyers or non-buyers. So this is called a validation. So when you go for validation in a discriminant model, 2 types are there. As I said, when I have the 40 observations initially, I may use the 20 observations for developing a model. That is, and remaining 20 hold out sample for later on validation purpose. Whether my model is able to validate that, means classifying correctly or not, I can use it. That is the one option. Other option is, instead of dividing the whole data as 20 separately, all into 2 groups, it can take the whole 40 observations to develop the model. Then, how it can do the cross validation? Suppose I want to do the cross validation of the first customer. What it will do now? So it will leave that first customer because we would like to classify. From the remaining 39 observations in the back end, it will do the process and it will say that the accuracy rate. That means it will classify. Similarly, when it comes to a second person, the second person left out. Okay, the remaining 39 observations are used for cross validating. So instead of validating the model with a separate sample, in the same sample also we can validate By that is called the leaving one out cross validation. So every time we are leaving a one person, and then with the help of the remaining, we are cross validating that. So that is what the procedure here you can check. That's what I given, cross validation. See, this method is known as the leave one out classification method in SPSS. That is, each time one observation is deleted, and from the remaining observations, a discriminant model is estimated. And using this discriminant model, the excluded case is predicted to belong in a specific category. So there are two types of cross validation. One is separate sample, or within that sample observation also we can go for cross validation. So validity of the discriminant model we can check. Then the classification table. That means accuracy level. So you can see that one, the classification accuracy. That is what the buyer into buyer group, non-buyer into non-buyer group. So let us understand now with the help of example. There is no SPSS table. Here only display. Okay, so it is there in PGDM. Okay, so let us take this first example. Okay, so this is what I explained now. So the same thing I will do it. The same example, what I given, a simple one. What is that? Variable you can see, buyer or non-buyer of a product. So in my example, I have taken here only 18 customers. Okay, so totally 36 customers are there. 18 out of that 18 divided into two groups. One group is for developing the model, remaining 18 observations to validate the model. Under that 18, I have equally divided as 9 are buyers and remaining 9 are non-buyers. Okay. Now I have the data of their scoring on different attributes. Okay. First of all, I define variable. Buyer or non-buyer category, it is a, I explained already. So this is the values. What is this one? It is a categorical variable. So non-buyer is taken as 0, buyer is taken as 1. So it is a discriminant, the nominal data. So it is not a scale, it is a nominal data. One has to highlight it clearly. Okay. The remaining are durability, that is the interval data. Then the lightweight in the yarn, that is what the wool manufacturing, low investment, rot resistance. Now, I have this information about them. See, totally 18 observations are there. So, 0 means non-buyer. These are the buyers. What is their opinion about this durability? This data is taken for a 10-point scale, not 5. Sorry, I think I explained that time 5. 10-point scale. What is the importance of the durability for the first person? 9 out of 10. 90% is important. For second person, lightweightness, 80% important, 70% and 60%. That accordingly as given. Third person you can see. 100% importance for him, durability, when you go for buying that. Okay. Whereas for other people, it is not so much. Look here. For 9 and 10, so it is only 40% is durability. They are giving not importance for durability. Okay. So this is what the scoring they have given when you make an interview with them. So it's the interval data. I know already that out of 18, 9 are buyers, 9 are non-buyers. And I have their scores also. Using this score, now I will develop a regression, a discriminant model. How to do that? I'll go to analyze. And classification is there, classify. So classify is a discriminant model is there. So I'll click this discriminant model. Now what is the grouping variable? Buyer and non-buyer is a grouping variable. What are the independent variables? In the independent variables are durability, light, low distance, this one there, durability. Okay, 4 independent variables. Now when you go for here, you have to define the range also. If you have only 2 groups, it is a dichotomous. But you can have more than 2 groups also. Okay, so 3 group, 4 group, etc. So what is the defining the range here? Minimum value is 0 because it is a non-buyer group. Maximum value is 1, that is a buyer group. Continue. Then only this is highlighted. Now you can do whatever you want. Basic statistics. If you want the mean value of each durability, standard deviation, you can highlight this one. Then univariate ANOVA, if you want, you can highlight this one, univariate ANOVA. Okay, let me check that one. Continue. Then classify. Case leave out one, leave one out classification. Summary table I wanted. I think other things are not required. So continue. There is no missing value. Save. I want the predicted group membership. I wanted the discriminant scores also. I want the probabilities also. Okay. Then continue. Now you press this OK. See, these are the discriminant scores. Directly, immediately it has calculated. So when I use that model, so what is the discriminant value for the first person, for buyer, for a first individual? What is the discriminant score? 1.06093. Whereas for the second person, the discriminant is 0.28, etc. So like that way, we have the discriminant score. Similarly, discriminant 2, discriminant 3. Okay. Let me go to variable view, data view directly now. Look here now. How many customers we have taken initially? 18 customers. Now these are the group basic statistics only. For the non-buyer group, for all 4 variables, what is the average scoring? Average scoring of the durability, lightweight, the standard deviation, usual descriptive data. With respect to the non-buyer group, buyer group. Then combining non-buyer and buyer for 18 observations, this is the average value. So everything will be provided in the SPSS output. That is the basics. Okay, if you want, you can use that one discriminant. At present, we don't require averages and all. Now, if you want to test for equality of a group mean, that means if you want to use that usual F test, F test or T test we are doing. The average values of the 2 groups are same, not same. That means with respect to durability and lightweight, between durability and low investment. Usual t-test we are doing, whether there is a significant difference with respect to the average score of durability and the rot resistance, durability and the other one. So that highlight is, that is also highlighted. So what you can say that durability is significant here, you can check, and other variables are not at all significant because p-value here it is lesser than 0.05. So it is significant, you know that. So p-value lesser than alpha 5%. So it is significant. That means when you go for classifying the individual or a customer as a buyer or a non-buyer, what is important? Durability is important. Durability is an important variable to classify he is a buyer. So that is the only variable is a highly significant. So that is why the significance is mentioned here. Anyhow, let us go further. This is what the canonical correlation. Do you remember? Just now I explained theory. What is the meaning of canonical correlation? You have to square that value. It will tell you what percentage of variation the dependent variable explained by independent variable. So what percentage? 0.71 square. So that means 49 and around 51% it will come. So 51% of variation, okay, in the dependent variable, that is buyer or non-buyer, explained by these four attributes, like durability, rot resistance, lightweight, etc. So that is what the canonical correlation interpretation. Next, we can check the Wilks lambda. Wilks lambda is what? 0.492, lesser than half. So we can say that the model is significant. So our discriminant model is quite good. And look at this value. It is also saying that it is significant. 0.042 is lesser than half. It means our discriminant model is significant. So what is actually the discriminant model here? We should write that one, no? Discriminant model, how do you write that one? We have to go for structure matrix. This is standardized. Oh, I didn't check that. Okay. I should have checked that unstandardized coefficient. It is giving only standardized coefficient. So in the unstandardized coefficient, you are going to have the constant value also. That constant is left out here. I did not check, I think. I checked only the standardized. Okay. How to write this model? Anyhow, if it is a standardized model, then how do you write that one? You have to write that one that y is equal to. Then what is the value there? 1.219 x1 star because it is a standardized variable converted into standardized. Next one is what? Minus 0.104 x2 star. Like this, after looking into the output, you have to write the model. And you can observe here only the durability is only positive value and others are negative value. What does it mean? Durability increases the probability of a customer becoming a buyer, whereas the negative probability indicates that non-buyer. It makes him into non-buyer. So the probability will be increases when the durability value increases. So these are inversely related. That means this will help to classify the customer into non-buyer group, whereas durability helps to classify into buyer. And structure matrix is the correlation. That what is the structure matrix? Look at this one. Okay, this is a structure matrix, 0.911. So lightweight. What is it? Structure matrix. It is a correlation between structure matrix I given in the theory part, you know. So durability value is this much. Okay. Structural coefficients. So structural coefficients of the predictor variables are useful in finding the relative contribution of the predictor variables and discriminant between the two groups. They are nothing but the correlation between the discriminant score and each of the independent variables. Okay. So that means now come back to that sheet. I'll explain. What is the correlation here? 0.911. That means it's a correlation between that discriminant score and then the individual variable. Similarly, very high correlation. Discriminant score is very much affected by the durability. Similarly, the correlation between the lightweight and the function, lightweight, low investment, etc. In fact, rust resistant is the least bothered. It is a 0.068, 0.068 to almost 0. So this is what the structure matrix. Then the group centroid means value. As I told you, there are only two groups and both the groups have equal number of observations. So their mean value is the same. So using this, the cutoff score is taken as 0. Cutoff score is taken as 0. Next, we are classifying. Look here, probability we are taking it as 0.5. Either you can do it in two ways. You can classify the person belonging to buyer group or a non-buyer group on the basis of the discriminant score, actual discriminant score compared to the cutoff score. The another way is that probability compared to the cutoff value of probability. The normally cutoff value of probability is 50%. So this is what the 0.5, the prior cutoff value, 50%. So if any observation is for value, probability is more than 0.5, he will be classified into buyer group. If it is less than 0.5, classified into non-buyer. There are two methods. One is comparing discriminant score value, okay, with the cutoff score for classifying. Another one is comparing the probability of that value, discriminant score probability, with the cutoff value probability to classify into buyer or non-buyer group. So when you go with the probability, we take this as a 0.5 probability. Okay. So if we take the cutoff score value, here the mean cutoff score value is 0 because you can see that one. Buyer and non-buyer is a minus 9.58 plus 9.58, 0 divided by 2, it is 0. So 0 is a cutoff score. So two ways you can classify the person into buyer or non-buyer. So that is what the SPSS will tell. Then finally, what classification we have? Okay. Look at this one. Originally, the non-buyers were 9. But our model, that means that model what I explained, standardized score or unstandardized score, will able to classify correctly only 7 out of 9 people. Means 2 people are misclassified. So what is the accuracy level of classifying non-buyer into non-buyer? 77.8%. So my model is able to classify non-buyer into non-buyer to the extent of 78% only. But when it comes to a buyer category, here, how many of them are classified? 8 out of 9 people. Totally 18, no. So 8 people were classified correctly as a buyer only. 1 is misclassified. So what is accuracy level here? 88.9%. If you want the overall accuracy, whether it's classified as a non-buyer or a buyer, but how much accuracy in my model in classification, you can take this plus this average. So approximately it will come 83 or 84%. Okay, when you take the average of these two, that is my overall accuracy of my model. So this is from the original data. Suppose if I use a cross validation, I explained just now already what is the meaning of cross validation. Okay, so if I use the same data with the cross validation, how it happens, how it is classifying. In the cross validation, you can see that one out of 9, 6 were correctly classified, 3 were misclassified. In buyer group, 7 correctly classified, 2 misclassified. It means here the accuracy level is 66.7, here 77.8. When you take the average, it will come around 73, 74. So it's quite good, reasonable. If you get a accuracy level of above 65, 70 in your model, that is reasonably good. That means your model will able to classify into 2 categories. So this is what the discriminant analysis, classification purpose. So let us in future, in the coming internship program and all, that means your research work, project work. So you can use one of these models, like regression model or this discriminant model, or coming some more models, you can use it for your study. Like in organization, if you want to classify. Okay, so classify on various way. You can classify the high income, low income, or different categories you can classify. You can take a HR example, marketing example, or any other type of example. As I said, the banks. Okay. Bank you can classify. Normally we have the different banks, both commercial banks, both private sector and the public sector. And some banks are huge assets. Their number of branches are more, number of customers are more. Okay, so they can be considered as a large bank. Okay, whereas there are some banks, even though they are an old one, they are the nationalized banks only. That means a public sector bank, but still they are not doing very well in the performance. The performance is not so well. Correct. So the number of branches may be less, or maybe the other reason. You can see that one share market value. If you see, HDFC is a private sector bank. Where is the share price of that one? ICICI, or even if you take, that means people have more trust on them. Correct. Yes Bank is there, IndusInd Bank, or newly recently bank. Whereas if you take earlier bank, the traditional, that is a public sector like a Vijaya Bank, Syndicate Bank, very large history we have, long old bank. But where are their share prices? Still they are 52 rupees, 95 rupees. People are not willing, means something is a government. So we can classify on a different way, on the basis of their assets, on the basis of the number of branches they are having, on the basis of the number of customers they have. So some way we can classify that one as a large bank and a small bank. Okay. After that, what we can do? We can develop a discriminant model and we can classify. We can cross-check whether our model is able to predict correctly as a large bank or a small bank. So what are the parameters important for banks to classify as a large bank? Whether the profitability is more important, liquidity is important, or return on equity is important, market value is important. So what are the important factors to classify banks as a large bank? Similarly for a small bank. So all these things you can understand with the help of this discriminant model. So highly useful application related models these are all. So every field you can use this model. Okay. So that is about the second model. So take 5 minutes break, even I have to make. And okay. So I'll continue now. See, I told you, two ways of classifying. Look at the probability now. As I said, probability is 0.5, no? So below 0.5 classified into one group. There is a non-bias group. Above probability 0.5 grouped into first, classified into first group. Look at the first customer. First customer, originally he is buyer because this one is a value. He is a buyer. Now, what our model does, whether it will classify him as a buyer or a non-buyer. So we can check. Look at this compare. This is a probability. 0.88429, no? This probability. This is a discriminant value. These are the probability actually. This is for non-buyer. This is for the buyer. Probability. This column indicates the probability and of non-buyer. This is the probability of the buyer. You remember when I checked that analyze and all, I highlight that one also, probability. So it is displaying the probabilities now. So what is the probability? These are the discriminant score. It is telling these are the discriminant score. Whereas these are the two probabilities. Okay. So these are the probabilities. So what is the probability? 0.88429 means more than 0.5. So there is a 88%, 89% chance that the first respondent could be a buyer. So he is classified into buyer group only. The probability is very high. And again here also 0.6312, more than 0.5, classified as a buyer only. And look at this one, 0.98, 0.98, etc. When it comes to this customer number 9, originally he is a buyer. But what is the probability here? 0.21, lesser than 0.5. So this person is misclassified as a non-buyer. So taken as 0. That's all. Whatever that report coming, that is how we have to understand. Similarly, when it comes to non-buyer probabilities are very high. Therefore, they are classified as 0. And here, if you want to, you take any one of them, either this or this one, if you difficult. So this is for discriminant score for a buyer and this for a non-buyer. So when you say the probability lesser than 0.5 classified as 0, 0, 0. But look here, this fellow, that means a customer number 12 is originally non-buyer. But what is his probability based on the model? 74%. So more than half. Classified as what? Buyer. So it is a misclassification. So that's how you can compare. Or if you want to compare on the basis of this value, discriminant score, discriminant score, then also you can classify. How to classify? Forget about the probability. I told you no, cutoff score is what? 0. So if it is more than 0, classified as buyer, less than 0, non-buyer. Look at this one. First one is more than 0, classified as a buyer only. Buyer only here. Look at this one. This is less than 0. So this person classified as non-buyer. Whether if there are two methods are there. Either using the discriminant score comparison or you can go comparing with the probability. Any one. When you compare with the probability, cutoff value is 0.5. But when you compare with this discriminant score, the cutoff value is 0. Less than 0, classified as a non-buyer. More than 0, classified as buyer. Followed? Huh? Then the default 0.5, 50%. That is depending upon the researcher. That is only depending. Default is a 0.5. If you want, you can change it. Okay. If you want, you can change that cutoff value. Okay. So default value is 0.5. 0, no. 0, what happened is calculated. It came. See, I think you can go through that table. I'll show you here. Here, you know. I told you, here what happened, the average value here we are getting the same because in both the groups you have equal number of people. So when you take the average of these two numbers, it is 0 only it is coming. That is the cutoff score. So that is a function of group centroid. So you have to give, So I have told you how to go for cutoff value. Cutoff score I give, It is two groups. Two different cases. If you have the different sample size, then this should be the cutoff score. Okay, so I'll do one thing. I'll go to one more example if you want. Okay, so this is the data, bigger data. Look at this one. What is this one? There are 7 variables. So the 7 were so many variables, like a classification of high user and low user, High user and low user of the internet. So time spent on a weekdays, time spent on a weekend, then linking with that one, messaging, networking, all these ones different variables. So we are classifying as what? Low user or a high user as a variable. So we have to take that one as table view. You can see that one. We have so many variables we have. Okay. We have the data like this. So now, using this data, you can run a discriminant model. I think it should be given. Where is the variable is given? Time spent. News update, games, education, job seeking, and okay. So we don't have a data on this one. Dependent variable data we don't have here. I think I missed it out or something. That means these are the variables to identify buyer or a non-buyer. I must have sample data, no? So initially I should have some 50 or some sample size, and I should have the data for all these variables. How much a person respondent spends the time on weekdays, weekends, for this purpose. Okay, I must have a data. Using that data, I have already classified as a high user or a non-user. Then only I can cross-check with a model. So I think the dependent variable is, I think you have that book there, no? This was given book. I think I've seen that one, no? This book. There is a standard book for text on this problem only. I given from there. Discriminant score I given. You can go through that. I given taken the same example to explain. See here what they are saying. First of all, in the previous example directly I given that 9 buyers, 9 non-buyers. The previous example just now. Whereas this example, so I have given a set of data, variables from 1 to L, 14 variables are given. But here the customers are not classified. He has collected the data sheet is here, the same thing I have given. The respondents are how many totally? Around 61 respondents are there. So the scorings are there here in this sheet. But they are not classified as high user or low user. And in the question only they are telling us to classify first of all as low user and high user. How to do that one? Look at this one. Divide the sample into two groups. One that is using the social network site for less than 1 hour on weekdays. Less than 1 hour whoever is doing is taken as a weekdays, low user. And the second, which is using the social networking site for 1 or more hours user. Then you have to use it. So, there is a weekdays only. This is a weekdays, you know. So, what you have to do now? Look here. I'll do that one now for this example. So, you have to classify. This is the data related to time spent on weekdays. Now, time spent on weekdays is given as how many? 4. Less than 1 hour, 1 hour, and here. What the problem is saying that you can make them into just two groups. Those who are using less than 1 hour is a one group, 0. The other remaining 2, 3 and above, another group, high user. Okay? Okay. How to do this one now? We want to convert this one into two groups only. What you have to do? You have to go to a transform first. So you have to make a variable, group into different variables. Recode into different variables. I am using this one. Okay. So what is the variable I am taking time spent on a weekday. I'll take this is a variable I want to change, x1. Okay. So you can give the new variable name. What variable name I can give? Okay, let me give that something. Let us say that y, I'll give that variable as y. Okay. So what is the variable you can say? Grouping variable. Grouping variable. So some name I have given. Okay, you have to change this one now. How to change that one? You have to go for old and new values. Now, what is the old value we have? Old value is 1 for less than 1 hour, no? So I'll use that one new value as 0 for that. Okay, so now add. So that means that system will understand wherever you have the 1, there are less than 1 hour user, taken as 0. Next. Remaining we have to go for add on the new value. New value is not a single value from 2 to 4. Okay. What I will do? I'll go for a range. I'll go for a range 2 to 4. 2, 3, 4. No, it was there. Okay. So I'll take it as 1. Okay. So I'll take this one. Then add. Now here you see. 2 through 4, it will take it as a 1. So, continue. Now, okay. Now look here. I have added the one variable as a 15th variable, y. That recoded now. So, what is the value for recoded value? It is not a scale, it is a nominal data now. Okay, transform variable data change. Okay, let it be scale only, no problem. So you can go to data view now. You can see that one data view, 15th variable, y variable. You see, 11110. Got it? So those who are using less than 1 hour considered as a low user, more than 1 hour high user. Converted now. It was not there. Now you can go for a discriminant model. So how to do that one? Go to analyze, then classify. In the classify, you have to go for discriminant model. Then you can, grouping variable is what? The last one, y is our grouping variable. Then define a range. Minimum is 0, maximum is 1. Continue. Then here you have to take all these variables. That means time spent on weekends you don't take, because they are the two different categories questions. So let us take other variable like light. Okay. Take this independent. Then all these things, whatever you wanted, statistics, I don't require a means, no one thing. I wanted only direct data. So I'll go to classify. Time, see, actually time spent is not a one of the variable to classify. See, question what is given in that question, there are two things are there, two questions. First, you develop a discriminant model using the weekdays using. One more model using the weekends time they are using. So we can do the two discriminant model. Okay. I don't take it as an independent variable. Because weekdays, how does it depend on the weekends time they are using? Weekends are used to classify as a high user or low user. For that, how the weekend they are using will become a dependent variable. It is illogical. So I am not using that. Apart from that, they are using for what reasons I have taken? Charting, blogging, education, other than the time spent. Okay. So that is what I have done. So summary table, if you want the layout summary table. So this is what the continue. Then save, predicted group membership, discriminant score, probabilities, all these things you can score. Okay. So now you can use directly. These are the discriminant scores, whatever I explained. And this is the output. See, totally 61 observations. These are the group statistics is coming. The average value, eigen value, canonical correlation, very, very low, 0.43, 4 square. So 17% only variation explained by these variables. Again, Willis lambda is not significant because you can see probability is very high. So discriminant model is not good here. Okay, we are getting the data, answer, but it is not good as per our conditions and all. These are the standardized coefficient to write the model. And then here the group centroid. Okay, functions of group centroid, what you can do, you can take the average of these two. Next, classification table. And grouping. Prior probability is 50% for classification. So these are the values. And you can see the classification rule. So 65% are classified, 70%, 4% misclassified here. Original. In cross validation, 48% and 51%. Sorry, 50% and 51%. Not very good classification. Okay. So this is what the discriminant model. You can do similarly for weekend times using also. So discriminant model is one of the models for classification, the multivariate technique. So wherever you want, you can use that one. As I given an example, a most popular example like a bank classification or customer classification, in HR classification. So if you're able to get the data accordingly, you can use all those things for your project work. This is not? That's what here I didn't do that one. So there is only option is there. No, there are two methods when you go for variables. One is enter variable. Enter technique means all the independent variables will be taken simultaneously. Another one is a stepwise regression. Model only will take one by one variable, adding and deleting. That way we can cross check. So for example, it will give, when you do that one, it will give 3 or 4 models. Then you can check that probably the 4th model with a less number of variables may be a more significant in classifying. Similar like a multiple regression, same thing. So that option is there. Okay. So this is a discriminant model technique. So discriminant model requires that assumption, that normality assumption of the data. Explanatory variable must follow the normality assumption and other assumptions, whatever has been. So more than this discriminant method, nowadays the most popular, the extended version of this model is useful, that is called as logistic regression model. So the next model would be logistic regression. So in this logistic regression model, these assumptions are not required. Okay. So if the assumptions are violated, we cannot use the discriminant model, but we can use the logistic regression model based on the odds ratio. Okay. So that is what the next model, that is what we are going to learn, the logistic model. Again for classification only. And if you take only 2 groups classification, it is a dichotomous classification. But if you have more than 2 groups classification, it's a multinomial. We can do that one also. See, we have taken only buyer and non-buyer category, or high user and low user. So instead of just only high user and low user, you can make it as a 3 categories. Okay. So medium users, high, low and medium. So it becomes a multinomial. It is an extension of binomial. That means extension of the dichotomous. So even education, we are making the grouping of the people, How we are grouping? Based on the education. Below metric, one group. Metric to up to graduation is one group. Above graduation, post-graduation, PhD, etc. is another group. So where they belong to, you can classify. Similarly, in an organization, salary-wise, below some salary is one class of people. The medium, the high range salary, another group. So same way here, we can classify more than 2 also. Okay. But let us anyhow start with the once again the 2 groups only. So that is a logistic regression. So if you understand this discriminant analysis, this is very easy. Only added component here is we can make use of the logistic regression. This log odds also we can use it. It's a logit function. Logistic regression is nothing but it is a logit function we are using for developing the model. Therefore, it is called the logistic regression model. So absolutely same as discriminant. Same examples I can run here also. I will run the same example. Okay, some difference I can explain here. Otherwise, classification only. So classification is very important in our data analysis nowadays, particularly in the marketing field and all. After that, we have one more technique that is called as a cluster analysis. That is also grouping of the people based on the similarities and dissimilarities. Then we have the latent group classification. So these are the different available techniques. Okay. So now there is some advanced techniques also in complex data analysis like artificial intelligence, etc., are also there. So then only you can think that, okay, I know something about the data analytics and you can become a data analyst. So these are the traditional regularly used models only. And for your project work, you can use one of them as a tool for your study. It depends upon what type of data you are collecting. Okay, so you can use. So it is a classification problem again, category. So I will go a little fast now. So examples of classification, same thing. Same examples there, but I have given some more examples along with those examples given during a discriminant. You can think about these type of applications. That is a customer churn in the organization, credit rating, like a low credit, and that means the risk for the bank when they go for giving a loan, low risk, high risk, or a medium risk. Employee attrition, you can take as a classification. Fraud, classification of a transaction to fraud and a non-fraud. Outcome of a binomial and multinomial experiment. That means we can classify a people based on whether he smokes or not smoke, he drinks or not drinks, skips the class or not. That means you can classify, no, he's a good student or a bad student. What are the parameters? We can take about whether a student is a smoker or a non-smoker, whether it's a drink or non-drink, skipping the class or not, takes a advanced mathematics, something like that way. Independent variable I can define. So it is a continuation, it is in fact extension of that discriminant. So logistic regression attempts to classify the customer's units into different categories, like I say, 0 and 1. Okay. Dichotomous categorical response. Survived, died, CHD, no CHD, low birth weight, normal birth weight, etc. So it is a independent, dichotomous, categorical variables, you know that one, social class, race, etc. Based on the continuous means age, weight, gestational age, etc. Before going to logistic regression, just explain what is the problem with the linear regression. So linear regression is a straight line, whereas the logistic regression is a S-shaped curve. Either the values will be concentrating very close to 1 or close to 0, correct? We have seen, if it is higher to closer to 1, classified as a one group, lower to 0, classified as another group. So that is the same thing here. So then obviously it cannot be like a linear. So I am explaining here the problem with the linear regression, what we did in our previous classes. So transforming the independent variable does not remedy for all the potential problems. That means when you have the no linearity in a regression also, what we do, we can transform the variable. For example, we can take a log of the data. Suppose if the y is not linearly related to with x1, x2, etc. That is the main assumption for linear regression. What we can do, we can change that y variable to a log y, transformed variable. This log y may be linearly related. That is what we did in a multiple regression analysis. But what is the problem? It is not possible all the time. That's what, even though that is possible, not always working. See, transforming the independent variable does not remedy for all the potential problems. So what we have a non-normally distributed dependent variable. So there the assumption is what? The normality assumption. So if it doesn't have, then what is the meaning of that one? For that, we coming out with a new type of topic that is called the logistic regression. So just I compared with the problem of linear regression and moved to logistic regression. So a problem with the linear regression, these are the problems. Same thing, pitfalls of the linear regression, whatever we have studied, there is a continued here. So for this approach only we are going with, see, it cannot be linear, so it will come. A problem with the linear regression, anyhow. So a problem with the linear regression, therefore we get the format like this, with the S-shaped curve. Problem with the linear regression actually should have come on that multiple regression only. Here I am making just comparative analysis. You can go through that later. So this is what the data I have taken. The logistic regression. This is a simple linear regression. If you get a shape like this way, almost like a S shape, most of the values concentrated near 0 or concentrated at 1. It is a sigmoidal curve. It is called a sigmoidal curve. It is a S-shaped curve. Okay, so this is a proportion. You can see that one. So you will get a S-shaped curve here. This is an example. So binomial logistic regression means only 2 values. Multinomial means more than 2 categories. Okay. So what is the function here? So it is a logic form we are taking. It is a conditional probability. What is that? The logistic regression model is the one explanatory variable. You can have many more also. That is in the next slide. So just for initially for one independent variable, model is represented like this. What is the probability that the y value given x, for this particular given x value, probability of Y. I'll tell you like this way. What is the probability that the bank is a large bank? My interest is what? To say that this particular bank is a large bank. Based on what? Based on the ROA of that bank. Return on asset of the bank. If the return on asset of the bank is very high, I would like to consider that bank as a large bank. So, what is the probability of Y given that independent variable X? So, that probability can calculate in this form. So, which is equivalent to write it. That means, if you don't want to write like this way, if you want to understand in the form of linearity like this way, like earlier model, then you have to change here itself. What happens? Log of Y given X whole divided by 1 minus of that will become a linear function. Means, probability of occurrence of an event divided by 1 minus probability of occurrence of event. So this ratio, log of this ratio is a linear function. This is called the logic transformation. It is not directly linear. In the regression model, why we used to write Y is equal to beta naught plus beta 1, etc. Even in the discriminant model. But in the logistic regression, we don't directly that Y is equal to. We write it here in terms of probability. Probability of Y given X. Like this way. If you want to write this one in a logic form, that means in a linear form, then what you should do? You should take a log of this function, probability versus over 1 minus probability. So that is nothing but a linear function. So what does it indicate as beta 1? Beta 1